Hello, my name is Evgeny Gromov. I am a development team leader in BricsCAD. In this demonstration, I want to show you new tools and features which we prepared in variational modeling. Variational modeling in BricsCAD was already very powerful and flexible, but in version 22 it will become easier and more comfortable in use. All new things will be shown on parts of this lift model. Let's start from new settings. In BricsCAD 22, we made a lot of changes which will be mostly imperceptible but still valuable. We united several direct modeling commands with appropriate classic versions, so dm_extrude, dm_rotate, dm_move commands, now deprecated, are just aliases of extrude, rotate and move commands and will be removed in future. Such uniting led to adding new settings. One of these settings, move face, controls behavior of the move command in case if face is selected. There can be moving of whole solid, as you can see now. Default option is moving a face surface, like that. And a new option is moving face edges. In this option, face will be internally substituted by face edges, and the move command will work as you select all edges of the given face, like that. It is convenient in case if you need to move edges of face but do not want to select them all the time. Next part of changes in modeling settings is introducing extrude mode group of settings. They control default behavior of extrude and revolve commands. Let's check how they work. Let's draw a circle on this plate and we'll try to extrude it internally. We will get just intersection between new solid and the existing plate, while we wanted to create a hole. One possible solution is to choose subtract option in the extrude command, but if you mostly want to create holes when extruding contours inside solids, it is easier just to change default behavior in settings. So you need setting resolve intersection with parent entity and option subtract. Then you will always have subtract as a first option of the extrude command when you're extruding contour inside parent entity, and you will not spend time on option switching. Next two options will be shown on these connected beams. Options resolve intersection and resolve touching with parent entity control what will be done in case of extruding outside. By default, new solid will be created and command will not check intersection with others. But if you want, you can change it. For example, you can set that you want to unite new solid with parent one and resolve all intersection by subtracting this new solid from others. Let's select this face to show how it will work. You can see that extruded solid united with initial one, so extruding looks like elongation. And here this new solid subtracts itself from intersected solid. Due to difference in working approaches, in freeform modeling, BIM and mechanical, values of these settings are different for different workspaces. And the last option in the extrude mode group of settings controls will adjacent surfaces created in extrude and revolve commands be united or not. Let's create 3 lines which will be geometrically adjacent. But they are independent entities, and it is up to you to decide should surfaces created in extrude and revolve be united or not. As you can see here, just one extruded surface entity was created. By default, they will not be united to have compatibility with AutoCAD. There are two more new options: copy-guided 3D source faces and sketch-based feature. Let's check why do we need them. To show work of sketch-based feature, we need to make some preparations. We need this assembly with wheels. Let's imagine that we will need to change these wheels. For example, we will need to change radius or width or some other parameters. What should we do? Previously, we would say that we need to use direct modeling tools or 3D constraints. But now we have one more solution of this problem: sketch-based features. So, what do we have and want? We have an existing wheel, and we want to make it parametric. First, we need to get profile or sketch of this wheel. So, as you can see, we are removing all these fillets, chamfers, this side hole. Same operation should be done from the other side also. All these fillets and chamfers are actually not a part of profile, but just some additions. So we need to remove them all to get real profile. Central hole also should be deleted. Then we can use the section command to get sketch as a region. Remove initial wheel, since we do not need it anymore. Here we have actually two united sketches. To divide them, firstly we need to draw a line in the middle, imprint this line, and remove redundant parts. Now we can use extracting of edges or just the explode command to get curves from this region. And we need to replace these notches by just one line, because they are also not a part of profile, but some subtractions. Next step is to join all these lines together to form a polyline. Great, we get profile of this wheel. Next step is to parameterize given profile. It is a very technical task, so work will be speeded up. Let's fix one corner to prevent unpredictable moving. Then we need to add several dimensional constraints, which will define wheel radius, rim thickness, and other required parameters. We need to add several geometric constraints, for example, perpendicularity between all edges, equality, and linearity on some edges. To check that parameterization is correct, we can use command animate on all parameters in the mechanical browser. As you saw, profile was created correctly. Finally, all preparations are done, and now it is time to switch on settings sketch-based feature. Many users wrote to us in support requests that they want associativity between initial contours and solids created in extrude revolve commands. Because sometimes it is easier to parameterize sketch than 3D solid, and sometimes it is even impossible to parameterize 3D solid, because spline faces will be produced. So, sketch-based feature add possibility to have such associativity. When this setting is switched on, initial sketch will be placed in block. As you can see, all constraints and parameters are preserved. Special extrude or revolve feature will be created. Then you can use link to parameter to connect feature properties or parameters inside sketch block to parameters in model space. As you can see, we already create simple parametric wheel. We can change parameters of sketch, and solid created from the sketch will be updated. Let's save it and insert to initial assembly. You will see that sketch-based feature open huge perspective of creating parametric models. First, we need to remove previous non-parametric wheels. This one and the small one too. It is inside subassembly, so it should be removed from mechanical browser. Then we will use the xattach command to insert new wheels as external references. In BricsCAD 22, we prepared for you not only parametric blocks, but also parametric external references. So if initial file has parameters, it will be xattached as parametric xref. Here we need to insert one parametric wheel instead of big non-parametric wheel, and we also need to insert another one instead of small one. And move it a little. Let's check how they will work. We inserted two wheels, but as you can see, there is intersection between them, and we need to do something with it. These inserted wheels are external references, but have parameters. So we need to change radius and central radius for one wheel. It will be transformed into a parametric block, but it still stores information that it was created from external reference. Why is it useful? We will show you. As you see, we forget to add central hole to our wheels. Do we need to recreate wheel, again remove existing wheels, insert new version and change parameters for one of them? No, just modify and reload. First step is to add central hole. We do not want to draw new hole, while we can just use hole from initial non-parametric wheel. To select hole edges, we can use edge network quad command, and then extract selected edges and remove solid and redundant lines. This is contour of our central hole. Then we need to copy it to our parametric wheel model. What next? Extrude it, and since sketch-based feature settings is still switched on, we will get extrude feature. Wait, we again forget one thing. This central hole was not parameterized. and we get extrude feature without sketch parameters. But it is not a problem. Sketches of sketch-based features has in the mechanical browser command edit sketch, which allow you to modify it after feature creation. Let's use it and parameterize this contour. We again need fixation, radius of this hole, and width and depth of this protrusion. And again, use animate to ensure that everything was done correctly. Now we almost finish with wheel. Let's again link hole parameters. Here we will get 3 new parameters: hole radius, hole width, and hole depth. Use animate on them to check that wheel will be updated correctly. Then we need one more small thing to make wheel and hole parameters consistent. Hole cannot be bigger than central radius, so let's add some new parameter, desired hole radius, with same value as actual hole value. And change actual hole radius to be a minimum between the desired hole radius and central radius minus hole depth. If we do not perform this, and after some changes central radius become less than central hole, topology will change and extrude feature will become invalid. And again, use animate on parameter desired hole radius to check that it works correctly. Now we are ready to save the file with wheel and return to initial assembly. As you can see, we have a pop-up message that external references were updated and we need to reload them. Even though we change parameters of one external reference, it is reloaded correctly, so both wheels now have central holes. We still need some small adjustments. For example, we need to rotate bigger wheel to make central hole to match with pin, and for same purposes we need slightly change hole parameters for small wheel. Here we need to change desired hole radius, hole width, and hole depth. As you can see, even after reloading, it can be modified parametrically. So, sketch-based features, in combination with parametric blocks and parametric external references, open huge possibility of creating reusable models. Another interesting part of changes relates to fillets and chamfers. It will be demonstrated on this rail guide model. So let's open a copy of it. As you can see, there are chamfers around holes and on sides of this part. We want to replace side chamfers by fillets and just remove chamfers around holes. How we can do this? Of course, we always can just manually select required faces, but now we have faster way. As you saw, we use new tool which allows to select chamfer with same offsets. It is part of the very powerful dmSelect command, and if you want to feel full power of this command, you need to call it directly. It allows to select faces, edges by attributes like area, length, and a lot of other possibilities. But it was in previous BricsCAD version. In BricsCAD 22, we added selecting of chamfers. So you can select all chamfers network by some seed face or add filtration by offset value. Next step. We need to add simple fillets on these 4 edges. It is required because then we want to add fillet on whole side chain of edges. And it will not be simple fillet. It will be next new tool of BricsCAD 22, fillet with intermediate radius. How it works? Firstly, you need to specify some initial fillet radius value for whole selected chain of edges. For example, here let's set 5 mm. Then you have possibility to select any point on initial chain of edges and set another radius for this point. Let's change radius on the end of this chain to 10 mm. You can change radius not only on ends of edges but anywhere on them. Let's change snapping mode to nearest and choose some arbitrary point here. And another one. And this is what we can achieve. If you decide that you do not need some points, you can delete them using option Erase Point. Since we add these 2 middle points just for demonstration, let's erase them. Then you still have possibility to insert new points or to change radius of existing ones. After finishing with points insertion, you need to choose Apply Changes option. Here we have our fillet with intermediate radius. Let's change its color to make it better visible. Same thing should be done on the other side of this rail guide part. Let's create another fillet on these edges. Here we want to have 0 radius for ends and some constant radius for middle arc. How we can do this? If we set 0 radii for both sides, all radii become 0. So we need firstly set intermediate radii for arc ends and only then set 0 radii for chain ends, like that. Also, we can remove these small redundant faces from both sides. And again, change color of faces. And here we have such a beautiful fillet. Let's also create fillet on the closest chain of edges. Due to high stress on this rail guide, we want to add some reinforcement to it. Again, we can manually select all required edges, but in that case we easily can miss some small one. So it is better to use Edge Network quad command to select them automatically. Intermediate radius fillet can be used on any smooth chain of edges, open or closed. Here we can set smaller values on left and right sides, because they do not get too much stress, and we do not want to spend material on that. But we need bigger radii on top and bottom sides. and apply changes. We can again change color of this fillet, and this is what we get. Let's save it and replace initial rail guide with the changed version. We will need this rail guide part to show our last new feature. Finally, we get to a last but not least feature, which we want to show you. In previous version of BricsCAD, our intelligent copy-guided feature allowed you to easily and quickly copy 2D geometry to other similar locations. Now, in BricsCAD 22, same powerful feature is available for 3D solids and blocks too. So I am glad to introduce you the copy-guided 3D command. Here is lift frame assembly, to which we inserted our new rail guide part. As you see, there are 3 places to where it should be copied. All these places have similar topology, so we can use it to automatically detect where our part should be inserted. We need to copy not only rail guide, but all adjacent parts, like bolts, nuts, and washers. Since we want to copy it not to the same but just similar place, we need manually select what we want as source faces. I will tell you further what is it. Just believe me that it is what we want to do. Here, to correctly define position, we need only 2 whole faces and 2 planar surfaces. And that's all. Now we can move entity near the place where it should be copied, and command will find you exact place where it should be. So we need to copy it here and to 2 bottom corners. Very fast, easy and enjoyable. As you can see, everything were copied correctly and to right places. Again, let's save it and replace initial one with new version. Here our new frame assembly with our new rail guides. Now let's check in more details what the copy-guided 3D command can do. Here you can see a frame which is a part of an elevator system. This frame will hold the motor to power the elevator, as well as some other wheels for the elevator cable to run over. And here we can see the holes that will be used to mount these wheels. And we want to add some reinforcement to this location. First, we will add some extra thickness to this location by making a simple plate. So just draw a rectangle and extrude boundary which it will produce. And here is our plate. We created one additional support, but we need it in some other locations as well. Instead of repeating all these steps to create more supports, we can use the new copy-guided 3D command. When detail will be selected, you will see a transparent box with preview of your detail. This box will be seen in blue color when the detail is in the free space of the drawing or when there is no placement detected. When a placement is recognized, the box will turn green. We also see some transparent faces attached to our selection. This represents source faces. Source faces are automatically detected when a detail is selected. These faces will determine the placement of the detail according to its surroundings. When we later try to place the detail, the command will detect the similarity between the source faces and the geometry of the new position and will place the detail accordingly. Here you can see another detail. Like the plate, this rib gives the beam extra strength in these mounting positions. As you can see here, this rib is snapping onto the channel of this beam, but it still has some movement allowed, meaning that no faces is forcing it into a specific placement along the beam. If you do have some allowed movement, such as in this scenario, you can hold down your Shift key. This will make the detail temporarily stick to the faces it has detected, allowing you to move your cursor around freely, while the details stays in the channel. Right now, however, we want the rib to be placed in the same way it is currently placed in the original position, and we need manually change the source faces. Here we see which source faces are selected. To change them, we can reset the selection and select all new faces, but currently we can just add one hole from the beam. Now, when we try to place the detail, you can see it snaps into the place immediately, and there is no movement allowed. So adding the extra source faces helps us to place it precisely where we want it. Here is how our whole motor frame assembly now looks like. Here you can see the frame model that we worked on earlier, which is now completed and added to the main assembly. But if we look over here on the counterweight of the lift, you can see the model is not completed and there is still some work to be done. This is a good opportunity to show that the copy-guided 3D tool is also able to copy several solids and blocks at once. And you know the parts will be placed correctly. Like before, with more parts selected, you will get a similar preview and the same functionality as you saw before. So we select several plates and place them to the opposite corner of the model. Let's check that everything is correct. Then we need to do the same operation with railguide detail. We still have two places on model bottom to copy our parts. We did copy in two steps, but of course it is possible to work with a larger selection as well. So let us select all these parts for the remaining locations. On this model, there are a lot of various faces. Therefore, the command can sometimes generate more source faces than needed, as you can see here. This could result in a slight performance drop or just make it slightly more difficult to place the detail. This makes it useful to have the option of selecting your own source faces. And as you will see, not many faces are needed to be able to place the detail correctly. Now we can copy all these parts into their new locations. As you can see, sometimes the detail will be able to orient itself in a few ways. Therefore, we can use the Ctrl key to toggle through the available positions until we find the correct one for this situation. So here you have seen some of what the new copy-guided 3D tool is capable of. It will allow you to easily copy details into new locations, and you can model with confidence knowing that they have been accurately placed. And it is all what we want to show you. As you saw, new tools and features increase the power of variational modeling in BricsCAD 22. They allow you to spend less time on routine tasks, give you freedom of designing, and open new possibilities of working with parametric models. Thank you for attention.